iTest.BTS is a set of automation software that is designed to automate battery testing equipment. It combines all the different types of devices that are typically utilized for full battery testing, cell testing, and pack testing. BTS integrates all the test devices automatically into one simple user interface so that the operators no longer have to individually program and control each piece of equipment, like cyclers and thermal chambers. iTest.BTS takes the data from each individual device and aggregates it into a single human-readable text file. It is also capable of operating discrete I/Os so that you can make measurements from the system like infra-cap-based I/Os, which are used with temperature thermocouples, digital inputs, and digital outputs. iTest.BTS can also interface any type of PLC that would be controlling infrastructure. Let's explore some of the basic iTest.BTS setup. This application is called Solution Builder. It is the offline configuration environment for iTest.BTS that can set up several different devices like cyclers, chambers, chillers, cameras, for example. In this cycler configuration example, we have selected an Ethernet cycler from AeroVironment or Webasto, an electro cycler, and a 2-channel NHR Skippy cycler. This means 4 channels are connected to iTest.BTS, demonstrating one of iTest.BTS's big advantages. It can control cyclers and chambers from different manufacturers, all within one environment. iTest.BTS uses a battery specimen file to drive everything for testing batteries. This file contains all the data about the battery itself, like minimums, maximums, and it also contains the test environment or the test requirements like low, high, and cell voltages. Because iTest.BTS uses this battery specimen file, each of the schedules that are used to test the system can be utilized to test virtually any battery simply by changing the listings, data, and parameters in the specimen file. This schedule is a simple static capacity test, so it does a discharge and a charge. This shows the current voltage and power set points have all been parameterized so that when the test runs, the schedule running will go out to the battery specimen file that has been selected for that particular channel, and it will read the current rate discharge, the voltage discharge, the power discharge, as well as the charge rates for all 3. It will substitute those values instead of any fixed value, allowing you to run virtually any battery using the same schedule, without having to write a different schedule for each battery. Let's look at the iTest.BTS test environment. This is the main startup screen for iTest.BTS. It displays control circuits and an instantaneous readout of various data like current, voltage, power, amp hours, and watts. This is where you would select which test you want to run on that particular circuit with its attached cycler, then you would select the battery. If you're not sure what battery or parameters to use, you can view and edit the battery specimen table, unless that specimen is being used on another channel. This center display shows the actual schedule that is being run for each selected circuit. A listing of circuit parameters can be expanded by simply right-clicking to display any parameter that's attached to that circuit. An array arrangement display is used. To view amp-hour charge for circuit 2, go in and select amp-hour charge, and it will specify a particular array that anytime this number is changed, it will go ahead and select those parameters once the system starts. So, let's start circuit 1 and circuit 2. Currently, the schedule is named SCT1 and it's on circuit 3, so let's change it to circuit 1. This is a display that will pop up if the battery, or test, has been run once before on that particular battery, so it will ask if you want to restart the test from the beginning. Now, we're going through a battery startup on channel 1, and that startup is complete. BTS will begin initializing communications with the BMS and start stepping through each individual line item on the schedule for the selected circuit. You can see values changing, which is another feature of iTest.BTS. Our offline development environment will allow you to make changes to your configuration, then verify those changes are running in the test before you take down a test cell or a cycler to execute the test. One of the things that iTest.BTS does behind the scenes is when a circuit starts running, it will look at the schedule, compare the schedule to the parameters in the specimen file, and compare and validate it to what the cycler can do. If for some reason there is a set point or a step in the test that violates any of those parameters, it will stop the test. Let's start tapering on circuit 1 and circuit 2. Other displays allow for monitoring of individual circuits. Let's shut down the battery so we can see some animation. The yellow highlight indicates that the test has been completed. You'll also see a banner that lets you know that the test is completed on that circuit. Here is the monitor circuit preparing circuit 1. There is our dialog box to verify that the monitor is running. It's monitoring circuit 2. You can see it's starting now. It's mounted in the circuit. A chart can also be displayed. For example, this is a current discharge, so you can see the current dropping, and the voltage is slowly dropping as well. You can also monitor multiple circuits. This shows all 4 circuits that are available in the iTest.BTS environment, and it allows you to start, stop, pause, and restart each circuit. This shows a display of all the values of different cells within a pack, like their minimum and maximum values, for example. The data files can be read by selecting the data log viewer. The data file format is a DAT delimited CSV file. Here you will see the numerical data. If you would like to evaluate the data in a graphical format, you can click the Evaluate Data button, which pops up a screen to view the data graphically. There is also a chamber display to view the chambers for the different circuits. For example, if you're using 2 chambers and you've got 4 circuits, you can have 2 little circuits in the chamber where temperature and humidity can be changed on a particular circuit. The BMS screen displays all the details for the BMS, supporting up to 4 separate CAN bus channels per battery pack. When the system is running, this would display the cell voltages in each respective bus along with some other generic parameters. From here, you can map your parameters using an application called Flex Edit. You can select the CAN bus file, and then you can go in and map them to the predefined BTS parameters. You can also add parameters to map the CAN bus. We also have an online report generator that will use templates to create reports. This concludes A&D's brief overview of the capabilities of iTest.BTS. For more information, visit www.a&dtech.com and contact us to schedule a full demonstration.